there. Today we're talking about CSCL gets to work towards collaborative learning in the workplace. And the goal is that though we are doing our research in formal learning settings, specifically in project courses, we would like to use the principles to inform how we might inject collaborative learning experiences in the workplace, where similarly there's project work that people are doing. And in the workplace, the focus is entirely on productivity, and we'll argue that in a project course, there's actually a problem of too much productivity focus. In the classroom, the reward structure encourages an overemphasis on productivity over learning, and this is actually a frustration of project course instructors. Now, in the workplace, bosses like the idea that and actually intend that the reward structure encourages this. But if we're going to inject learning into the workplace, we need to be able to shift the reward structure or shift the focus of the work. And so that's how we see the bridge between what we're doing in the classroom and ultimately in the workplace. And specifically in connection with team formation, which is the focus of this symposium, what we're going to do is talk about how effective team formation might set up teams for a learning orientation and effectively learning together. So we're going to talk about a construct which many of you are probably familiar with called transactivity that grows out of a Piagetian learning framework. And we're going to talk about its social and cognitive underpinnings and how that motivated the development of an automated team formation strategy. We'll mention briefly that this has been validated both in a lab study and in a massive open online course. But then we're going to talk about testing the generality of those findings in software teams. And as I mentioned, in a formal learning setting with the goal of eventual application in the workplace. And these two studies both challenge the generalization of that effect. So let's start out by talking about transactivity. Transactivity, very simply defined, is a property of an utterance that shows that it expresses reasoning and that it connects that reasoning to a prior expression of reasoning, most likely contributed by another student in an interaction. And here's an example from an environmental sciences unit. A student has expressed a proposal related to using coal as a form of energy in a city, and another student has responded by partly agreeing with that, but challenging it and extending it in two different ways. And this meets our requirement because it refers to the reasoning in a previous utterance and does it by building with its own original reasoning. Now, we did not invent this construct of transactivity. In fact, it's been investigated in prior work in the learning sciences and has been shown in that prior work to be associated with higher learning gains, higher knowledge transfer, better knowledge integration, and more effective problem solving than teams that have exhibited lower transactivity. But in our own research also, specifically the research of Ka-Jin Kwan, in her dissertation, she identified that high transactivity groups also exhibit positive social dynamics, and that these in conversations are associated with sociolinguistic indicators of a desire for common ground building and mutual respect. And it's not surprising because in a Piagetian framework of learning where the construct of transactivity was first developed, the idea is that it marks places referred to as indicators of socio-cognitive conflict that are opportunities for potentially triggering a cognitive conflict. And the idea of a cognitive conflict in that framework is that it's more likely to arise in cases where there's power balance or mutual respect between the individuals who are interacting. And so we see that transactivity, importantly, has both cognitive and social underpinnings. And because of that, you could see the observation of transactivity exchanged as a signal of collaboration potential between pairs. And in fact, in Miao Wen's dissertation research, she leveraged this indexing of collaboration potential in an automated team formation paradigm. In her paradigm, which she tested both in a lab study context and also in a massive open online course. Students would first come into the course, they would do some individual work, they would post that work to a public discussion forum. Then the class as a whole was assigned the task of offering feedback to 2 or 3 other students in that discussion forum. And then an automated analysis of transactivity was conducted in order to compute for each pair of students an estimate of their collaboration potential depending upon the concentration of transactivity exchanged. And then this was used by a constraint satisfaction algorithm to assign the students to teams. Note that all students in the course were assigned to teams. The question was just which other students would they end up with in their teams. And the idea is that students engage differentially across other students in different levels of transactive behavior, and they will use more transactive exchange with students who they respect and who bring out the best in them. And so to the extent that this observed transactivity exchange really indexes collaboration potential, we expect that these transactivity formed teams would perform better than their random counterparts. And in fact, in the lab study and in the MOOC study, we see evidence of this. So here in this talk, what we're going to do is talk about the generality of those findings in software development teams. And as mentioned, we're going to observe this in a project course where software development is what the students are doing. So in fact, this is situated in a large online 16-week cloud computing course. This is it includes both graduate and undergraduate students across 3 of Carnegie Mellon University's campuses, Pittsburgh, Silicon Valley, and Rwanda. And this offers the challenge to our paradigm that in the prior studies, the team assignment was kind of forced on students. They didn't have a choice. But the culture of this particular online course is that usually students got to choose their own teams. And now we're introducing automated team assignment. And we're offering it as a suggestion, as students could choose not to take up that suggestion. And in fact, that's mostly what students did. So using this paradigm, the entire course was divided into 3-person teams using this paradigm. And those recommendations were given to all of the students, but only 5 out of the teams actually took up the recommendation. So what we see here is that the culture and expectations that students brought with them into the course based on 10 prior offerings of this course at Carnegie Mellon thwarted the uptake of the recommendations and therefore the potential for positive impact, similar to when a doctor offers the best of medical advice, but a patient nevertheless refuses to conform. What we did see was that regardless of whether the students chose to take up the recommendation or form their own teams, we could compare the level of criterion transactivity of the teams that were auto-assigned in comparison to the teams that the students self-selected into. And even if they self-selected into a team, because we can nevertheless compute that criterion score, we can then look at how that criterion score predicts whether the students, the extent to which the students performed well in their teams. And the students were producing software together that was auto-graded, and we do see a significant positive correlation between the criterion score and the auto-graded software quality score of the teams. What we did see was that students did not self-select into teams that were as high in the criterion score as the auto-assigned teams. So in fact, they chose to put themselves in teams that the method would predict would be less effective than the ones that they were assigned to automatically. Students were most likely to select based on their friendship. And in the end of the semester, we gave them a post-course survey, and we asked them about their experiences in their teams and also how they formed their teams. And what we found based on that was that teams formed based on friendship were most problematic. They complained about division of labor and relationship issues significantly more than teams that were formed either based on the automated assignment or based on student observations of other students in the course that showed that they were intelligent and that they had a good work ethic. The teams that were based on those kinds of observations were not significantly worse than the auto-assigned transactivity-based teams. So either approach had evidence of actually being a positive way of doing things, but unfortunately, students seemed very desiring of actually just working with their friends. So a second challenge is that transactivity-based team assignment can be regarded as an implicit structuring of the group or an implicit way of scaffolding group processes because it sets up the teams to have good work processes. But another thing that we could do is offer explicit support for these processes, and that might be seen as a stronger intervention. And in fact, that contrast has already been made in the last CSCL in Xu Wang's work. In our study, all of the teams were scaffolded in their processes using what we call mob programming, an emerging paradigm for software development coming from industry. And there are 4 roles that are associated with mob programming. The driver, who is the only person who gets to actually directly add software to an interactive development environment. A navigator, who is kind of directing the work, and people who are playing what's called the mod role, where they get to weigh in and challenge. They might be looking up information. They might be discussing what they're seeing, evaluating what's going on, and then a facilitator who's kind of directing the discussion. In our particular implementation of this, the facilitator role was played by a conversational agent. And the roles rotate, so students have the opportunity of seeing the process from all of these perspectives. Now, this paradigm offers a lot of advantages, and in our long-run goal of being able to inject collaborative learning experiences into the workplace, it has these positive qualities and seems to be an environment where we think that this might work. One is there's a clear division of responsibilities and there's kind of a shared cognition going on where it's never on one person's shoulders to drive the process forward. Students have the opportunity to learn from one another, and they don't default to roles that they're good at because the roles are assigned and they rotate. So this addresses a lot of the problems with the reward structure that really overemphasizes productivity, and it also addresses some of the problems that we saw with teams that were assigned based on friendship. So this was validated in a 3x3 Latin square design that was 3 different tasks, and then the conditions were transactivity form teams, random form teams, and individuals. And here what we see is that the scaffold of the mob programming was associated with task-relevant content discussed. So the extent to which students conform to the roles as they were assigned, rather than just ignoring those and going off and doing their own thing, predicted the level of task-relevant reflection that we saw in the discussions, and that was positive. However, what we didn't see was that the transactivity manipulation led to any other further positive effect over and above that. So in this context, it appears that the transactivity manipulation as an implicit form of support was much weaker than the support that's offered by the mob programming scaffold, and therefore might actually not really be that necessary. So in conclusion, we offer transactivity as an effective basis for team formation. This can be used in a totally automated method for team assignment. It's been validated in a large-scale lab study as well as in a massive open online course. However, when we tested it in its generality to software teams, What we don't see is that positive effect actually generalizing in the first case because students chose not to take the recommendations, and in the second case because it may not have been necessary anymore once the positive effects were scaffolded using a different means.